Picture this. It's late. You're sitting on your couch.
The room is totally dark except for the phone.
Right, exactly. The glow of your phone is illuminating the room, and you are just scrolling.
And scrolling.
And scrolling. And suddenly, it feels like, I don't know, every single person on your feed has spontaneously become a master animator.
Oh, yeah. Like overnight.
Right. Your entire timeline is just flooded with these stunning, whimsical, Ghibli-style art pieces. It's literally everywhere.
And it is so fun to look at.
It is. You're having an absolute blast, but because it is so incredibly fun and, so visually satisfying, you're probably ignoring the fact that we can't really trust our own eyes anymore.
No, we really can't.
We are in the middle of a tsunami of synthetic content. Welcome to the deep dive, by the way. I'll be your guide today as we navigate this mess.
And I'll be here bringing the data and the source material to help us make sense of it all. Because it really is a complete saturation of the digital environment right now.
It really is.
You start questioning everything. Like, is that a photograph of a real protest, or was it, generated in a server farm somewhere?
Yeah.
Did your friend actually spend 20 hours painting that beautiful portrait? Or did they just type a sentence into a prompt box?
Which is exactly why we're doing this today. We are building you a detection toolkit. We're diving into the latest research, the forensic visual data, and the behavioral patterns of these generative algorithms to figure out how you can actually spot the fakes.
Spotting them is half the battle.
Exactly. And perhaps even more importantly, we are going to explore the psychological and environmental reasons why you might want to successfully step away from it altogether.
Because there are real costs.
Huge costs. Okay, let's unpack this. We have to start with the most immediate thing that hits your brain when you look at an image. The visual clues.
Right. So while generative models have made exponential progress in like a remarkably short amount of time, they haven't actually perfected the physical world yet.
They still mess up.
Oh, absolutely. They leave behind very distinct, recognizable fingerprints. And the most glaring example of this, the one that almost always gives the game away, is human anatomy.
Uh-oh.
Specifically, the hands.
The dreaded AI hands. I mean, it's so creepy. You look closely at this seemingly perfect photorealistic portrait, and then you glance down at the subject's hand resting on a table, and they have, 7 fingers.
Or they're missing a thumb entirely.
Yeah. Or the joints are bending in ways that completely defy human bone structure. But, okay, I have to push back here because this drives me crazy.
Sure, what is it?
If these models were trained on billions of photographs of actual humans, how can they not mathematically know by now that hands only have 5 fingers?
Well, what's fascinating here is that the algorithm doesn't actually possess a structural model of a human skeleton.
Wait, really?
Right. It has no concept of what a hand actually is or what purpose it serves. It is purely predicting the proximity of pixels based on statistical frequency.
So it's just guessing what color the next tiny square should be.
Precisely. And fingers are incredibly noisy visual data.
Noisy? How so?
Think about a photograph of a hand. Fingers overlap, they cast tiny shadows on each other, they bend at various angles, they hold objects.
Okay, yeah, that makes sense.
To an algorithm that is just looking for patterns of parallel lines and skin tone gradients, a cluster of 6 or 7 overlapping shapes statistically passes the test for hand-like texture.
Oh, wow.
Yeah, it understands the aesthetic of fingers, but not the anatomy of them.
That explains so much. It's mimicking the texture without understanding the underlying architecture at all. Which actually brings us to another major visual tell from the data, right?
The glossy sheen.
Yes. The texture of the images themselves, you'll often see this bizarre glossy sheen over everything.
It's the surface-level reality.
Yeah.
The models really struggle with the micro-imperfections that make real skin or real fabric look authentic.
It's like taking 10,000 photographs of different faces and mathematically blending them into one. All the unique, sharp imperfections, the pores, the tiny scars, the asymmetric wrinkles, they all just cancel each other out.
Exactly. They get averaged out.
Right. And what you're left with is this blurry, mathematically average smoothness that looks almost like plastic wrap.
That's a great analogy.
At a quick glance, your brain says, okay, sure, that's human skin. But then you actually stop and look at it and you realize human skin shouldn't be that unusually smooth. And a cotton t-shirt doesn't reflect light like a freshly waxed car.
It's a regression to the mean. The algorithm is applying a generalized smoothing effect because it's averaging out millions of data points.
Right.
And that same fundamental disconnect between aesthetic and meaning appears in another massive visual clue, background text.
Oh man, the gibberish text. This is hilarious to me. Why is it that an algorithm can render a perfectly smooth, hyper-realistic human face with complex emotional expressions, but it completely throws a tantrum when it comes to rendering the letters on a street sign in the background?
It completely falls apart.
It really does. You zoom in on a book cover on a shelf, and it's just like alien
It
scribbles.
goes right back to the hands, actually.
Oh, really?
Yeah. The model recognizes the visual aesthetic of typography. It knows that cityscapes usually feature rectangular signs with clusters of high-contrast shapes on them.
Okay.
But it doesn't know the semantic rules of spelling. It doesn't know that the letters STOP carry a specific meaning when arranged in that exact order.
It's just drawing shapes.
Exactly. So it generates shapes that mimic the idea of text, but when you look closely, they fail to form real letters or phrases.
So if the model doesn't understand basic human anatomy or how the alphabet works, it definitely does not understand the laws of 3D physics.
Not even a little bit.
If we move from what is in the image to how that image exists in physical space, things fall apart even faster, right?
Oh, the logic of the scene completely breaks down.
Yeah.
And the first place you see this is lighting and shadows.
Shadows are tough.
They're highly complex. They rely on a consistent light source interacting with three-dimensional geometry. If a model is just predicting pixels on a 2D plane, it often places shadows falling unnaturally.
Like pointing the wrong way.
Exactly. Or it creates lighting that is entirely inconsistent across the frame. Like the light might be hitting a person's face from the left, but their shadow is cast as if the light is coming from the right.
The researchers noted that traditional artists are usually the first ones to spot this because they spend their lives studying how light actually hits a surface.
Right. They have that trained eye.
But for the rest of us, it can be really subtle. And honestly, it is so exhausting for you, the listener, to have to act like a forensic lighting expert just to scroll through your morning feed.
It's a lot of work.
It is. You're trying to look at a picture of a cat, and suddenly you're analyzing the trajectory of a shadow like you're on a crime scene investigation.
It demands a high level of constant active skepticism, which is draining.
Yeah.
And beyond the lighting, there are what the data calls unfinished details.
Like what?
Blurry, distorted earrings or architectural shapes that just seem a little off in the background.
Here's where it gets really interesting to me. The straight lines.
Oh, yes. The bending lines.
The research points out that in these generated images, straight lines often aren't actually linear. A power line will start on the left side of the image, perfectly straight, go behind a tree, and then come out the other side at a completely different angle.
Or just melt entirely into the sky.
Yes. Why does it forget how to draw a line halfway across the screen?
Because of how the generation process actually works. Many of these models process images in localized patches.
Patches.
Yeah, they don't generate the entire image all at once in a single flash. The neural network might draw a perfect straight power line in patch A. Then it works on patch B, which is, say, a complex tree canopy. Then it moves to patch C, the sky. It completely lacks the global structural context to realize that the line from patch A needs to seamlessly connect through patch B and continue into patch C.
Because there's no underlying 3D structural integrity.
Exactly.
It lacks object permanence.
That's exactly it. And this lack of structural logic becomes infinitely more glaring when we move from static images to video.
Well, video generation is deeply unsettling.
It fundamentally struggles with the physics of movement. Observing unnatural flow, floating movements, and bizarre morphing expressions is a huge tell.
Like how people walk.
Yeah, how clothing shifts, how weight transfers when someone walks. It all looks slightly disconnected from gravity. It morphs unnaturally from frame to frame because, again, there is no 3D world being simulated.
It's just a sequence of 2D pixel predictions trying to look like movement. So, if the hands are cleverly hidden in pockets, the text is cropped out, and the video is just short enough to look physically convincing. What is the ultimate fallback? How do you actually verify what you're seeing?
The ultimate fallback remains the reverse image search.
Good old reverse search.
Yep. If you see an image that is highly inflammatory, shocking, or just, too perfectly bizarre, search for the source.
Right.
If the results show that this image is only circulating on social media platforms and it is nowhere to be found on any verified, reputable journalistic or educational sites, there is a very high probability that it is synthetic.
Because social media is an echo chamber designed for rapid sharing, not fact-checking.
Exactly. And as the models improve, the visual glitches, the extra fingers, the melting power lines, those will eventually get smoothed out.
Which is a scary thought.
It is. which means our verification methods have to rely on context and source literacy rather than just visual forensics.
But the deception isn't just limited to visuals, is it? These algorithms are churning out millions of pages of written text every single day.
Oh, absolutely. It's the exact same predictive architecture, just applied to words instead of pixels. We need to talk about the textual fingerprints.
Just like the visual art, the written text has its own set of distinct algorithmic tells.
Okay, what's the biggest one?
The primary one is the writing style itself. The research identifies a few key variations. The text often reads as highly formulaic and dull, heavily relying on structural transitions.
Like furthermore and in conclusion.
Exactly. Or, conversely, it can swing the complete opposite direction and become bizarrely poetic and flowery when the context absolutely doesn't call for it.
Oh, I've seen this. You ask it to write a simple email to your landlord about a leaky faucet, and suddenly it's writing a Shakespearean sonnet about the cascading tears of the plumbing.
It's ridiculous.
It really is. And the repetition. It constantly repeats and rephrasing the exact same concepts over and over within the same text.
It's padding the word count.
A human writer usually has an original thesis they are driving toward. The algorithm doesn't have a thesis. It just circles the prompt it was given, rephrasing the same basic data points using different vocabulary to simulate depth.
Okay, I have to ask about the most specific tell from the research.
The M dash.
The M dash. The algorithms apparently use long hyphens so excessively that it has become a primary metric for detection.
It really has.
But wait, I love using M dashes in my own writing, like constantly. Does this mean my coworkers think I'm a robot? Am I outing myself as a synthetic entity here?
I mean, you're fine,
Oh,
but it actually highlights exactly how token prediction works.
how so?
Well, why does a machine default to recognizable quirks like flowery language or endless hyphens? It's all about statistical weights.
Okay.
The algorithm was trained on millions of human texts, and it calculated that humans often use M dashes to convey conversational flow, dramatic pauses, or complex layered thought. When given a basic prompt, it tries to mimic smart conversational human, and it overcompensates. It aggressively favors those highly weighted tokens.
So it's trying way too hard to sound natural, and in doing so, it creates a caricature of human writing.
Which is why the researchers advise that reading multiple passages is the key to spotting the pattern.
So one M dash is fine.
Right. A human might use an M dash naturally or write one formal paragraph. But if you read a few pages and notice the exact same formulaic sentence structure, the constant circling of the same idea, and a barrage of stylistic flourishes, you are looking at a textual fingerprint.
Okay, so we've armed you with the detection toolkit. You know, to look for the structural anatomy failures, the mathematical glossy sheen, the localized patches where straight lines bend, and the heavily weighted tokens like endless M dashes.
You know how to spot it.
Exactly. But the researchers take a very sharp turn here. They move from the mechanics of spotting it to the hidden costs of engaging with it. Spotting it isn't enough. So what does this all mean?
It means that every time we choose to outsource our curiosity to these tools, we are making a trade-off.
A trade-off.
Yeah. First, on a purely functional level, there is the issue of hallucination. These models generate wildly false content and present it with absolute certainty.
But why do they hallucinate in the first place? If they have access to so much information, why do they just make things up?
Because they aren't databases retrieving facts,
Right.
They are probability engines predicting plausible-sounding sequences of words. You can think of them as the ultimate people pleasers.
Just telling you what you want to hear.
Pretty much. They are mathematically optimized to give you an answer that looks like a correct answer, rather than verifying if the information is actually true. They would much rather confidently guess a fake fact than admit they don't know something.
Which obviously damages our collective understanding of reality, especially if students are using them for education.
Oh, the impact on education is a whole other issue.
Totally. But there was another cost in the data that really caught me off guard. The environmental impact.
The compute power required to run these models is staggering.
Really?
Yeah. The research explicitly points out that if you have a question, it is far better for the climate to use a traditional search engine than to direct that same question to a generative bot.
I don't think most people realize this. Like, why does asking an algorithm to generate a picture of a cat or summarize an article take so much more energy than just Googling it?
Well, think of a traditional search engine like looking up a word in a massively indexed pre-existing dictionary.
Okay.
The work of compiling the dictionary is already done, right? You're just retrieving a specific page.
Makes sense.
Generative AI, on the other hand, is like spinning up an entire manufacturing plant to print a brand new, highly customized dictionary just for you,
Yeah.
right in that exact second,
Yeah.
and then immediately burning it down when you're done.
Wow.
Burning it down.
That's a crazy visual.
It's true, though. The inference compute, the energy required to calculate billions of probabilities in real time for every single prompt requires massive server farms. And those farms draw immense amounts of electricity and water for cooling.
See, you don't see those server farms heating up when you're just tapping on your phone screen.
Out of sight, out of mind.
Exactly. But the physical footprint is massive. And then there's the privacy aspect.
Yes.
This was the detail from the source material that genuinely made my stomach drop. Your personal content might be used to train these models, whether you gave explicit consent or not. And they specifically called out things like Google Docs.
This raises an important question about the boundaries of our digital lives. Data scraping doesn't just happen to public articles or published books. It can happen to the tools we use for our private thoughts.
It's incredibly invasive. You sit down to write a private journal entry or a rough draft of a novel or a business plan on a cloud-based document thinking it's your own private workspace. And the idea that your keystrokes are potentially being scraped, digested, and fed into a machine learning model just to help a bot sound slightly more human when it writes a marketing email for someone else, I mean, it's wild.
It forces us to ask, is a mildly amusing generated image or a slightly faster email draft worth that environmental cost?
Probably not.
Is it worth the silent sacrifice of your personal data privacy? The researchers argue forcefully that it is not.
Which brings us to the actionable part of this deep dive, reclaiming reality.
Yes, the practical steps.
If the hidden costs to our data privacy and our physical climate are this high, how do we actually step away? The source advocates for offline solutions.
The solutions are refreshingly grounded, honestly. The first step is simply breaking the behavioral loop of the screen.
How do they suggest doing that?
The research urges you to actively prioritize socializing with friends and family in real life. When your entire social sphere is mediated through a screen, you lose your baseline for reality.
You just get sucked in.
You do. And you become far more susceptible to doom scrolling through endless feeds of synthetic content.
The advice is literal, too. Whenever you feel the urge to pull out your phone and endlessly scroll, they say to physically stand up and take a walk outside.
Just go inside.
Yeah, it's about changing your physical environment to break the algorithmic trance.
And that physical, intentional approach extends to how we work and create as well.
Right.
The research strongly advocates for returning to traditional research methods instead of outsourcing your curiosity. And it speaks directly to artists and creators. Make your art the traditional way.
Brainstorm, draft, perfect it yourself.
Exactly. Reject the tools that offer to enhance your work.
It makes me think about the creative process like working out.
How so?
Well, using an algorithm to write your essay or generate your illustration is like hiring someone to go to the gym for you.
Oh, right.
Sure, it's incredibly convenient and it saves you a ton of physical energy, but you are completely bypassing the friction that actually builds the muscle.
That's a really good point.
You don't get any of the cognitive benefit of wrestling with complex ideas, of making mistakes, of finding your own unique voice. You just end up with the unearned result.
If we connect this to the bigger picture, it validates a very real psychological struggle. It is hard to give up tools that remove friction from our lives.
Of course it is. It's easy.
But the research emphasizes that doing things the traditional way, embracing the friction of learning and creating, is vastly better for your long-term cognitive health and the integrity of your work.
And it's a social effort, too. The research suggests setting boundaries. You can delete the apps, but if your group chat is still bombarding you with generated memes every hour, you're still in it.
You're still consuming it.
Yeah. You have to be willing to tell your friends, hey, I'm taking a step back from this synthetic stuff. I'd appreciate it if you didn't send it to me. It's a tangible way to curate your own digital environment and protect your mental bandwidth.
You are choosing to curate the inputs you allow into your mind. You are choosing the real over the artificial, even when the artificial is engineered to be more, momentarily entertaining.
So look at the toolkit we've built today. We started by identifying the structural failures, looking out for the anatomically impossible hands, the mathematical regression of that glossy sheen, and the localized processing that makes straight lines bend and text turn to gibberish.
All those visual tells.
Right. And then we moved to the text. hunting down the heavily weighted tokens, the flowery language, and the endless M dashes of a model trying way too hard to sound human.
And from there, we mapped out the unseen physical costs of this technology.
The hidden costs.
Yeah, the massive energy expenditure of generative inference compared to simple database retrieval. And the reality of our private, cloud-based documents potentially being digested as training data.
And finally, we looked at how to reclaim our cognitive space, putting the phone down, changing our physical environment by just going outside.
Simple things.
Exactly. And refusing to let an algorithm go to the creative gym for us, choosing instead to embrace the friction of our own brainstorming and drafting.
It's so important.
It is. You have the power to curate your own reality. You do not have to passively consume the endless feed of synthetic content.
And as you take that step back and return to creating things with your own two hands, consider this.
Okay.
We spent a lot of time today analyzing how generative models fail because they can't quite capture the micro details of reality, right?
The missing pores, the shadows.
Right, the complex overlapping shadows, the
Yeah.
messy asymmetry of life. These algorithms are desperately trying and failing to mathematically smooth out the complexities of the physical world.
Because they just want the average.
Exactly. They're optimized for a reality that is glossy, frictionless, and perfectly predictable. But perhaps the things the algorithm fails at, the uneven textures, the asymmetrical features, the messy, chaotic, unfinished details of human first draft, perhaps those aren't flaws to be smoothed over. Perhaps our human flaws are actually our greatest creative assets. The next time you create something, whether it's a painting, a piece of writing, or just a spontaneous conversation with a friend, consider that those very imperfections are the undeniable proof of your humanity in an increasingly synthetic world.
Proof of humanity. I absolutely love that.
Yeah.
So the next time you find yourself on the couch, the room dark, endlessly scrolling through a flood of perfectly polished, frictionless artificial worlds, remember to look closely at the hands. Look at the shadows.
Look for the M dashes.
Look for the M dashes, and then maybe just turn the screen off, go outside, and take a walk in the beautiful, imperfect real world.